Year 13 short revision video number 17. So, we're given a question about a discrete random variable x, which can take the values 0, 1, 2, 3, 4, 5, and the probability of x taking each particular value is given by this formula. So, for part 1, find the value of k, which is an unknown in the formula. So the first thing that we're going to do is work out each of the probabilities. So the probability that x is equal to 0, well, if we substitute in here for x equals 0 and on the right hand side as well, we will get a value of 6k. So the probability that x equals 0 is 6k. The probability that x equals 1, this will give us 10k. So each time we're replacing little x with the value that we've chosen for it to take. So the probability that x is equal to 2, that's going to give us 12k. The probability that x is equal to 3, that's going to also give us 12k. The probability that x is equal to 4, that's going to give us 10k. And the probability that x is equal to 5, that's going to give us 6k again. Now, because x can only take the values of 0 up to 5, the integer values between 0 and 5, these probabilities are exhaustive. That means they have a total of 1. So the sum of the probabilities is equal to 1. So if we add these probabilities together, we get a total that is 1. So that is 56k, which equals 1. K therefore equals 1 over 56. Now, part 2. In 1/2 term, Ben attends school on 40 days. The probability distribution above is used to model x, the number of lessons per day in which he receives a gold star for excellent work. So Ben can receive a number of gold stars each day. The probability distribution tells us the number of lessons per day in which he receives a gold star for excellent work. So he could achieve a gold star in none of his lessons. He could achieve a gold star in 1 lesson, in 2 lessons, in 3 lessons, 4 lessons, or all 5 lessons. So part 2, find the probability that Ben receives no gold stars on each of the first 3 days of the half term. So that means day 1, day 2, and day 3, he's going to receive 0, 0, 0 gold stars. And he receives 2 gold stars on each of the next 2 days. So day 4, he receives 2 gold stars. Day 5, he receives another 2 gold stars. So how do we work this probability out? Well, the probability of x being equal to 0 was 6k, which is 6 over 56, because we now know what k is equal to. And the probability that x is equal to 2 is equal to 12k, or 12 over 56. Now, the probabilities can then be multiplied together in the relevant combination, and because the question has been very specific, we don't have to look at multiple combinations of how this could occur. The question's not asking us about the probability of him having 3 days with no stars and 2 days with 2 stars. It's very specific that the first 3 days have 0 stars and then the next 2 days have 2 stars. So that's going to be 6 over 56 to the power of 3 for days 1, 2 and 3. And then for days 4 and 5, it's 12 over 56 to the power of 2. So let's evaluate this. And it comes to a very small number, 0.000005647, etc. So for such a small number, I would round this to at most 3 significant figures, possibly even 2 significant figures. And it's small because we're only looking at one particular combination. Days 1, 2 and 3 specifically no gold stars, days 4 and 5 specifically 2 gold stars. This is a different question to if we were being asked to work out the probability of getting 3 days with no gold stars and 2 days with 2 gold stars in any order. So that is a very different question. And finally, part 3, we're asked to find the expected number of days on which Ben receives no gold stars. Now, the probability of receiving no gold stars we know is 6/56, and he's attending school on 40 days. So remember that probability is essentially a measurement of proportion. So we want 6/56 of 40, or 40 multiplied by 6/56, which comes to a value of 4.285 ... which I'm going to round to 4.3 to 2 significant figures, or 4.29 to 3 significant figures. We do not round this to a whole number of days. That's misleading. It then suggests that the expected value is perhaps exact at 4, when actually we're saying that the expected number is just above 4. So we're expecting just more than 4, so somewhere between 4 and 5 days on which he receives no gold star. So there's no need to round an expected value to an integer unless you're specifically asked to do so for a reason.